Bruna Teknik Förlag. Did I pronounce it right?
Yes,
Yeah, that's good.
Perfect.
Well, I'm here to present the Nordic technical specification. It's not a standard, it's a specification about fire safety engineering, and it's about comparative method to verify fire safety design buildings. Quite long name. There's a lot of information in it. And but I will also show how to do it in practice from a design view. And but I will show and also talk about the content of the specification, what is good with it, what could be challenges with it, and what will be the future with the next step on the Nordic collaboration. And if you want to stay after the 10, I will give some more information about technical guidance that we have in Sweden. We've got some technical guidance from the SFP chapter of Sweden, but also from the company that I work with, the way of best practice. If you want to stay and listen to that, you're welcome. But first, what organization do you represent here today? I know there are some consultants, designers, and I understand it's some person from the standardization organization, the building authorities.
Designers, the authorities, and designers mostly.
Designers mostly, yeah, that's good.
Fire authorities. Fire authorities.
Fire authorities, yeah.
Fire brigades.
With the uniforms. That's good. And I will take this presentation in English, but if you have a problem to understand what I'm talking about, don't hesitate to interrupt and ask, and then I will try to explain and answer your questions. And if I don't take it, if I don't manage to answer in English, then we take it in some kind of mixed Scandinavian. I can't speak Icelandic, but I think we could manage it in mixed between Swedish and Danish and Norwegian. Well, who am I then? Well, my name is Johan Noren, and I'm a fire safety engineer. I've been educated in Lund at the Faculty of Fire Safety. I think the name is now. They just changed their name about 5 months ago. Well, see if we can get on to see this. And at the moment, I work as a technical director at a company in Sweden called Rehab, Rehab is a consultant firm working with fire protection, like 85% of the time, from designing to doing the auditing when they have built the building, and doing some inventory work as well when the building is ready and been standing there for 50 years to see, are the fire protection good enough to fulfill the Swedish regulations. But we also do some kind of risk assessments according to land use planning. And we are about 40 consultants. Most of them are fire engineers, and they're working all over Sweden. But for my view, I've been working about 7 years with designing buildings. Even if I look quite young, I've been in the industry quite long, concerned to how young the industry is in Sweden. In Sweden, we started working with performance-based design in '94. If I'm not misinformed, I think you in Iceland started in '78, something like that. Is it right? That you got performance-based rules. Yeah, good. Well, most of my time I spend on doing this performance-based design, working with fire safety engineering methods to ensure that the design in a building is good enough to ensure to live up to the society's acceptable level. But I also do some risk assessment, a lot of the land use plan in Stockholm. And, but I also work some with business development as my role as a technical director at Breab. The last years I've been working a lot with guidance, internal guidance, and that's why I've been a part of this work with Insta 950 about the comparative approach. But last year I also started to do, if you stay after 10, I will talk more about this guidance, technical guidance, to see how we in my company have worked with this process to ensure a good quality, a good level of safety. But last year I also started to do some research in collaboration with Lund University, and I'm a member of a research group working with ascending evacuation and to see if fatigue, physical exhaustion will affect the evacuation concept. And ascending evacuation is when you walk upwards in the stairs, not downwards, that we usually do. And this is a question in Sweden at the moment because we're going to build a new subway line. And it's going to be about 100 meters underground. It's going to be a big problem to evacuate the stations. Yes. Well, if we go back to Insta 950, this is a technical specification. And why? Why do we need one? And I've trying to find why do we need this technical specification. I didn't really understand all the things that you said earlier, but I understand you talked about Insta in some kind, and you talked about the meaning of it. But this one, this Insta 950, is about fire safety engineering, and it's just about one part of the way of define if the level of safety is good enough. So it's and because of the system that we have this performance-based codes, and all the Nordic countries have got performance-based codes, and that means that we have these pre-accepted solutions that the society tells us you can do it this way, then the level of safety is okay. But you have also the freedom to work with fire safety engineering methods and take and change the design after the building. But then you have to ensure that the level of safety is good enough. You have reached the societal level of it. And because we don't have absolute criteria according to what is safe enough, the comparative approach is one of the most common verification approaches in fire safety engineering. But until this technical specification, there wasn't any guidance, any specification on how to do comparative analysis, or to work with a comparative approach, I should say, not analysis. You have to separate the approach and the analysis. But it's about to define how to do things. And the specification is a lot about the focus on how to do it. It consists of recommendations and the options, how to define, how to verify your fire safety design. And it's also about how to determine fire safety objectives according to these pre-accepted solutions to have. And also describing how to verify that it's good enough. Well, so you can say it's almost about describing how to verify fire safety design when there are lack of clearly defined acceptance criteria. And it's the comparative approach is about the acceptance criteria, not about the analysis. I will come more into this later on. But it's take it with you, and I will continue. But the Insta 950 is also important to get a standardized process to work after, to know how to do things and when to do it, in what order to do it. And it will give a more consistent and uniform process. And this is good that it could work as a guidance, not only for me as a consultant or designer, but also for the building authorities, the local authorities working with the auditing maybe. It's different from the Nordic countries in how the auditing will work out. Like in Sweden, we have a really liberal system, but we don't have any quality checks from the authorities, only the industry that auditing itself. I think it's really good also to have this standardized process to understand how the consultant should work and the authority to know how to do it. But it's also a good way to increase the Nordic collaboration over the Nordic countries. Well, this is nothing new to work over the Nordic countries. It's been done a lot of years before. And in the 80s and 90s, there was a good collaboration according to fire safety design, fire safety engineering, and it was a committee called NQB. I don't know the exact English translation, but in Sweden it was called Nordiska kommittén för byggbestämmelser. And I know that Björn Persson was a member of this committee in the early 90s, I think it was.
In the early
in the early 80s, yeah. You want to say something about this good old days?
It was really excellent work that was done, and we built the foundation for performance-based design and everything. And, it still is the same, it hasn't changed. It's the foundation for performance-based design. It was very good work that was done. I was not Icelandic representative, I was Swedish representative in the committee. It was very good work they did.
And that work is the foundation of this work. It's the next step, so to say. Because it's the same fire safety objectives that was defined in the early 80s, 90s. That is the fire safety objective that we still work with today. Well, to give you some background to this new specification, we have to see, I will tell you something about that. Well, the specification was prepared by the Inter-Nordic Standardization Cooperation, and it's named INSTA, but it's a part of the INSTA that work with fire safety design. And I think you got the information about this after the former presentation. When doing this specification, there were participants from all Nordic countries, and it was also participants from different organizations, building authorities, especially Norwegians, so a great part in work. We had standardization and research organizations, and we had consultants from Norway, Sweden, and we also have the industry with us, especially the sprinkler industry. And in Sweden, the sprinkler industry is working a lot about defining how could we do trade-offs with sprinklers when we designing our buildings. Well, the work was initiated by ESPI, which is the Technical Research Institute of Sweden. And it was a continuous work from earlier work with about verifying fire safety design in sprinkler buildings, which was a collaboration between the sprinkler industry and SP to define and make it easy to understand what the deviations can I do when I install a sprinkler system in a building. But it was from the Swedish way of fire safety engineering. But when the work started, they tried to see if it's possible to work in the same way in the Nordic countries. Well, when the work was initiated in 2011, I think it was a different objective. It was the organization wanted it to be in-depth guidance on how to perform fire safety. Not only the comparative part of it, but the whole, how to use the right kind of model to do your asset analysis, how to verify your safety level when you're calculating radiation between buildings and things like that. But over time, and because of the Nordic countries have different way of working with performance-based design, the scope changed. Especially in Denmark, you're not allowed to do fire safety engineering if it's a complex deviation. It's only allowed to work with this kind of methods when it's a small deviation from the preaccepted solutions. And they don't have any absolute criteria. They only work with the comparative part. And that's why the INSA 950 changed from being this in-depth, holistic part of fire safety engineering on a Nordic level to only focus on the comparative part. And my part of the work was that I started as a representative of the consultation body from the end user in Sweden. I was giving comments about how could I use it in my daily work as a consultant. But when the scope and the objective changed, then I was more and more part of the committee and was responsible to design and describe the process of a comparative approach. Do you have any questions about the why and background? No, then I continue. Well, because before I continue, I really want to make it clear the concept of absolute and comparative. It's easy to mix them, and it's easy to mix it with analysis and methods and approaches. But the technical specification is about the comparative part, and it's only focusing on what is acceptable or not. It's a level of safety we work with. And we usually, when we talk about engineering models and methods, we talk about absolute criteria. I'm gonna be, if I'm over 15 kilowatts, it's not okay, but if I'm under, it's okay. And when using absolute criteria, you have defined values that are defining the level of safety that should be fulfilled. For example, in Sweden, and I know you have here in Iceland as well, when you're doing the asset analysis, available safe egress time, you have some tenable conditions to work with, like the visibility, the temperature, the toxicity. And there you have some kind of absolute criteria to work with. And in Sweden we also have it when we work with the fire safety objective concerning fire spread between the buildings. If the received radiation is lower than 15 kilowatts per square meter, then it's okay. If it's over, it's not okay. But in a lot of fire safety objectives, we don't have this absolute criteria. And you need some other kind of approach to define if it's safe or not. And then you use an alternative way, and it's a comparative approach, and it builds on the concept of benchmarking against a pre-accepted solution and prove that the alternative fire safety design with your design that you want to design a building is at least as safe as the building designed with a pre-accepted solution. To benchmark against a building with pre-accepted solutions. So it's all about the acceptance criteria. It's not about how to analyze. Well, if we're going to go in depth to the technical specification, I can say it's we've got it here. Well, yeah. The specification is about 45 pages, and it's divided into 6 main parts, and it's built up like a lot of the standards, the ISO standards or the European standards or even the Swedish standards. It's in the same package. And the 6 main parts are the definitions, the process of comparative approach, different fire safety objectives, the uncertainty and sensitivity management, how to document, and the national determined parameters. It's possible for the Nordic countries to choose what part of this technical specification should we take in our country, and how does it match the building regulations. And like always, the fire safety objectives used to be the biggest part. It's like finding the mathematical model to describe something, or find this kind of magic numbers to put in your model. It's the things that I, as a consultant and designer, want to have to make my work as easy as possible. And it also describes how to verify these fire safety objectives. But and it's divided into sub-chapters, 7 of them, and it's the same 7 fire safety objectives that was defined by the work by NKB in the 80s and 90s. So you could see the red line between the former work and this work. And the 7 fire safety objectives are evacuation. How should I do when I do calculations and analysis about ASET assets? Do you know that ASET is the available safe rest time? How long time will it take until I reach tenable conditions? And the asset is how long time will it take for me to evacuate the building? We also have the fire safety objective concerning protection against generation and the spread of fire and smoke. Well, it's about dealing with the outbreak of fire. Where the objectives concerning prevention of fire, fire spread within the fire compartment. It's talking about different materials and surfaces and how it will react in a fire. We have this objective according to prevention of fire spread between fire compartments. And it's dealing with the separation of different fire compartments. And the fire resistance, what level should it have the class E60 or E30, and how do you deal with that? And the prevention of fire spread between fire compartments is all about the temperature. What temperature will it be on the other side of my separation? And the next one is stability and load-bearing capacity in case of fire. And it's like the Euro codes. How should we work with that? And of course, we also have this fire spread between buildings. What radiation could I allow? What the distance could I have between buildings? And what sizes of windows? And what kind of facade could I work with? But also we have the objectives according to safety for rescue services. and it's about the work and environment for the rescue services. When they go into a burning building, how should that be designed to ensure that there is an acceptable level of safety for the rescue teams? But for me, I think the process of comparative analysis is even more important than the fire safety of objectives and these medic numbers of models, because the medic numbers, I shouldn't call them medic numbers, but the input data to use and the model to take to analyze the problem. You can find it in different literatures. It's a lot of published in that matter, but it's not so much about the process of how to do things, in what order to do them. I think it's a really important part of it, part of the technical specification. But I also think that the uncertainty and sensitivity management is really important. And especially to know how much uncertainty you are putting into my fire safety engineering. And do I know how it will react when I have a failure with the power system? And the uncertainty and sensitivity management is about, especially the uncertainty and sensitivity analysis and the robustness analysis. And these words are usually, you use them very often, but I think it's important to understand what they really mean. And in the technical specification, we have defined them in the definition part. And uncertainty focusing on parameters that are related to lack of knowledge. I don't know the whole pictures. Like it could be misapplication of data, I use data that was from the 70s in a model for today or for the future. Do I know that this data was right for this kind of objectives? In that way, I'm going to use it now. But we also have this sensitivity that is about how much will the result variate when I change my input parameters. If I add it like 15% more or 15% less, how much impact will I have on the result? And the robustness is about the whole fire safety concepts and the dependence on different resources like electricity to the building. Do I need backup electricity to ensure that the function is that I want to have it? But I really think that uncertainty and sensitivity management is really, really important to have in mind. But when I work as a designer, I'm not a big fan of the process or the uncertainty. I just want to calculate and get a result and say, it's okay, come on, you can continue. But it's important to know how to work with these tools, part of it. To know where I could take a shortcut, and I know the easiest way to find my answer to my customer. And we also got this last one, is national determined parameters, because we don't have exactly the same system in the different in the Nordic countries. And